Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, we are going to start the main functionalities of machine learning. And here, the complete machine learning workflow has been divided into two parts. And yeah, dear friends, welcome to the first part of our comprehensive machine learning series. And in this session, we will delve into the foundational steps of the machine learning pipeline. And yeah, you will learn about the significance of data, how to collect and process it, and why these steps are crucial for building effective machine learning models. Yeah, let's join us and we explore the essential techniques and best practice for transforming raw data into a valuable insights. Dear friends, you would have come across this exact image along, of course, yeah. Artificial intelligence versus machine learning and deep learning. Yes, dear friend, artificial intelligence is a broader term that describes the capability of machines to learn and solve problems just like human. In other words, this artificial intelligence refers to the replications of human, how it thinks, works and functions. On the other hand, this artificial intelligence can be seen as a program that instructs the machine to function in a certain way according to the situation. There are two ways of incorporating intelligence in artificial intelligence, that is thinking. So is to achieve artificial intelligence through machine learning and deep learning. That means, yeah, through deep learning and machine learning, yeah, these are the ways for achieving artificial intelligence. And when coming towards this machine learning, yes, machine learning is basically the study or the process which provides the system to learn automatically on its own through experience it had and improves accordingly. Without being explicitly programmed, this machine learning focus on the development of the program so that it can access data to use it for itself. When coming towards this deep learning, yes, dear friends, this is basically a subpart of the broader family of machine learning, which makes use of neural network. Yeah, similar to the neurons works in our brain and to mimic a human brain. So like behavior, this deep learning algorithm focuses on information process or pattern mechanism to possibly identify the pattern. So just like on human brain does and classifies the information accordingly. And to be said, yes, deep learning works on larger set of data when compared to machine learning, and the prediction mechanism is self-administered by machines. Dear friends, here we are just specifying something to be done, how the human decide, how the human decision happens. Okay, let me just discuss what is the process of a human decision. So let us take an example from the medical domain, yeah, where a doctor is looking at some patient and he is trying to decide whether the patient has COVID or not. So the doctor might be looking at several factors such as spleen rashes, fever, headache or cold and cough or vomiting, okay, and so on, and decide whether the person has COVID. So for one patient, this was the situation, that is he or she had skin rashes, okay, did not have fever and did have a headache, had a headache and did not have cold cough and had a vomiting. And so on, okay. So, and based on these, the doctor decides that this person actually has does not have COVID or even nothing symptoms to be as like a COVID. And if we just take it with another patient, yeah, in the case of this patient, a different combination of features were exhibited. Some symptoms were there are some symptoms as like here there is no skin rashes, okay, and actually here we are having is in the sense of fever is there, headache is there, cold and cough is there, and vomiting is happening. Okay, by these symptoms, okay, were not, it was just enough for the doctor to conclude that actually the person might have COVID, okay. Now the question is, on what basis is the doctor making this decision? Exactly, dear friends. This actually, the doctor is making this decision based on the past experience. So, years of practice or the past few years of practice, the doctor has actually encountered several patients. Okay, so here it not only one particular record, he would just have so many past records, and from that, this exact decision making would be easy. And so here I have given you such like 4 patients. Okay, so for each of these patients, the doctor has accessed the specific set of symptoms that the patient exhibited, and also the final outcomes, whether the patient was diagnosed with COVID or not. This is what he had already dealt with in the past, and similarly this was the second patient. Kindly just see here with a set of different symptoms. In particularly he has skin rashes and cold and cough only. Okay, but the doctor knew that this is the case where no COVID, it not even a COVID, it can just have only this rashes and towards this cold and cough. Yes, right. So, based on to access to lot of such past data from the personal experience, the doctor, yes, of course, is now able to look at these symptoms and make some decision about whether the person has COVID or not. And now, since we are eventually interested in making the machine to take the decision, so we will go from these representation to the more numerical representation where this exact cross, okay, so this exact cross we will call it as like a 0, and the tick mark we will call it as 1. So since the machine understands numbers, we try to convert everything to number. So again, this particular row which just shows 1 0 0 0 0, yes, the first row is basically means that the person had skin rashes and did not have any other symptoms, and the output is 0. That means the patient did not have the symptoms related to COVID. So that is how you are supposed to read these. This is not very different from what I just showed earlier. Is that instead of cross in the tick mark, 1 is replaced them by ones and zeros, and now this is something that you call as machine readable input, which could eventually feed this into machine. Now such decision making appears in several domains. It is not just restricted to the medical domain also. So, but even say something like sports, right, where in cricket, there is an umpire who needs to decide whether the person is out or not. And let us see, look at specific case when the umpire needs to decide whether the person is LBW. Okay, so out or not, right? Okay, so now this again depends on various factors. It depends on whether the ball was pitching, whether the impact was in line, what was the height of the exact delivery at the time, whether the bowler had got a legal delivery or towards that no ball. Okay, so whether the batsman was attempting a shot, and so on. And so these factors actually act as an input for the umpire to make the decision. And in fact, a lot of us are not trained umpires, but we have watched a lot of cricket matches, and based on that experience, lot of us also become expert at this decision, right? So yes, dear friends, for the past viewing experience, let us just make it class like a viewing experience. Yeah, we would have seen this one case where the ball was pitching, okay, in the line, and the impact was in the line, but it was going over the stump, and so it this cross, and the delivery was legal and the shot was attempted. But in the case of umpire, this is not given as out. So now based on this and many such examples, yes, many such examples that we have viewing overall lifetime for this history of watching cricket, we start understanding that these are the factors which actually play a role, and not just that, we also start getting some sense of what kind of interactions eventually lead to the final decision. So like what combination of these exact factors lead to the position of whether it is out or not. And once again, these crosses and the tick marks, I could make them machine readable by just replacing them with zeros and 1. So it means again, in the first row, the ball was pitching and the line was impacting, okay, was in line, but the height was above this exact stump, right? So it was not within the height of the stumps, so on. And so that it how you read this data, and also the output, you could read that there is, or there, in all of these cases there was some decision. Yes, this exact some decision which was made, and now you have access to this decision, and you could represent it as zeros for not out and 1 for out. So now what it is that, yeah, we are using to make these decisions, right? So we want to understand what is the semantic of decision making, and there are mainly two things that clear, that is the exact role, and that is one of the thing is future and the other one is rule. So futures are nothing but all these inputs that we are taking in the case of daily example. Yeah, it was a skin rash or fever and a variety of other inputs are still intense, right? I just showed only 5 here. There could other things like some lateral board and so on. And then based on these decisions, there is something going on in the head of this doctor, yeah, which he tries to combine these various input in some kinds of rules based on these, okay, and take decision if true or maybe this 2 or 3 conditions of these conditions are on, or if more than 4 of these conditions are on, then it is pretty sure that the operation has taken, right, or any other further surgery or any other further treatment. So like that. Okay, so yes, now what we want to do is we want to outsource this task to a machine. So instead of a human making these decisions by various rules in his or her exact past experience, we want to able to translate that rules into the machine in a form of program, and then the machine should be able to execute this program by taking certain inputs and then give us an answer or output, right? So in particular cases, what we have done in this exactly, yes, of course, whether was this rule based in this, yeah, we have converted it into the into us like a set of program. So the exact set how would be, yeah, of course, it would be as like with an if and else condition, and for each of these if and else condition we have decided or defined what the output should be. And input for this program would be all these symptoms which are listed, and based on all these symptoms are fed to the program, and it could pass through all these if and else condition and gives us the final output. So which is whether the patient has or might have a COVID or not. So that is what an expert system looks like. It is a conversion of all these rules which are there in some human head or into or a nice program, or which can then be executed based on certain inputs and give the output. Now based on all these examples, okay, that we had which was as like an LBW or not, or we could imagine. Okay, so we could similarly use this if and else condition which looks all these factors And even when we just make it for an LBW, we have to look for pitch, we have to look for impact, we have to look for height, and all those combined there with an if and else condition, and based on the different permutation we could have the answer yes, of course it is an out or not. Now, so that let me just have, it is a typical and looks like an expert system. So now, even though these expert system looks like very simple, it is just some defines us like some if and else block that is written out, okay, and they are fine to have a lot of practical applications. So you could convert to a series of if and else statements when you could check if X is correct or if X is okay, and now let me just check with this Y. Or if Y is correct, go with an Z. If Z is not correct, then go with some other changes, and then again start over with X, and further so many things you can just combine as like an if and else combination. So these expert system find a lot of application in the real world, and actually if you look at a lot of industry driven application where AI agent have been used to make decision, a lot of them are driven by expert system where the domain experts in that area has written a lot of rules, and now an expert system is executing those rules to help other humans make the decision. Okay, now we are looking at expert system, and of course we saw that even the very simplistic that are useful in various practical scenario. Now we will try to discuss what are the limitation of an expert system and how do we overcome or try to overcome some of those limitations by using company knowledge was right or machine learning. Okay, so now let us take an example. So here we want to give an example as these are the exact futures, and what is this futures and what would be the exact output. Of course I want to hire a person, and now let us taking this example for hiring someone for a job, and the question that we are trying to answer is, do we need to look beyond expert system? Right? So now if you want to hire someone, you would probably look at various parameters. Again, that their marks in 10th or 12th marks, whether what is the graduation and what is the CGPA and so on. And during the graduation, what are all the past projects that the person has looked at, and based on these things you could imagine that hiring manager or who is responsible for hiring in the company, yeah, but for certain rules in their of course mind, yeah, that if a certain set of condition are satisfied and the person is hired, or if they are not satisfied, the person is not hired. Right? So that is what the output here we want to specify. So you could think of an expert system that is limited constraint setting. But now what happens if a various practical scenario including? That is this scenario where you are trying to hire some of a person, you are actually loading it with a lot of data, or you might actually have something that is in many factors. Na? So what are all the factors? Maybe as like 10th or 12th or graduation, CGPA, projects, and you would not just base your decision on these 4 or 5 things, but there might be many other factors like, yeah, the person have any publication in the past, or where in which language, or he or she is comfortable for any programming language, or how many years he or she has been programmed, what are all the database system that they know, or they are awarded, or having any awards that they have received in the past, where this award from organization or from client or from academic institutes, so on. So there are so many other factors on which you would like to base your decision. Now, so here again, every row that you see is the data for one employee that your company had or in the past thing, and for that employee have made factors or futures available on his or her 10th standard or 12th mark, whether he is or she is a graduates, and what is the CGPA and so on, number of projects and everything you would also know, because this person is maybe if you are known person, yeah, the person already working in your company, or if you would also know the output, whether this person was good or wrong. Okay, so you also have an output column here which will again be binary ones and zeros, and whether the person did a good job in your company or whether he or she had a good career in your company and so on. Now, what you want to do in that is actually, it is the based on this exact data. The exact data. Come up with some rules such that if you combine these parameters in certain if and else condition, and if you you would also have weights for some of these conditions, that CGPA is more than this percentage, or this exact 12th mark is more than this percentage or less than this percentage, or if the practical or if the project, whether they have a knowledge of only Python or Java, which and all it is important thing, anything else, then whether you should hire a new person or who has certain values for these futures. Just put it as like a weight and just specify. So you would have data for many employees, and for each employee you would have a large set of or a large number of futures dealing with the employee. So this leads to a lot of data which becomes very hard for you to make sense. And now just try this exercise. Given such data, how do you even start writing these if and else conditions? How do you relate the experience of C or Java or Python or the CGPA, or what are the connections with the CGPA and to the 10th grade marks? And how do you relate these in certain if and else conditions? In many real world problems, the first challenge that you face is you have lot of data to make sense for. And that becomes hard for a human to break it down into a certain conditions, right? So now, yeah, the second limitation, that is, even if I somehow visualize that you have been able to look all these data, and yes, of course, the rules you need to come up, you might just be too complex for even you write down something as like an if and else. If you just start writing the wrong rules, it would have so many permutations and combination, and of course it is become impossible at some point to remember everything and write it down as a rules. Maybe it will be too complex to be able to write them down. Okay, and in some cases the rules may just be inexistent. For an example, see, suppose in hiring manager, in addition to looking at all these quantities, metrics, okay, there might be something else. As like, yeah, I might say that I hired him because I saw honesty in his face. Now, how do you express this as a rule? And how do you say that, how do you even quantify something like honesty based on the interaction with the people or a person, or based on what you see in their eyes or what you see in their facial expressions and so on? There's something very hard to express. How do you write it up as a rule? So we have three problems so far, that is lots of data, lots of rules which are hard to write down, and sometimes the rules them are inexpressible, so you can't even write them as an conditions, okay, if then else condition. And last, the fourth challenge that we have is, yeah, sometimes the rules may just be unknown, unpredictable. So now, no matter how much data I gave you, or if you just have, or suppose this is a new disease, even though you can just say some new disease that is spreading, and you still don't know how one of the factors which are causing this disease. So you might look at a lot of symptoms, but a lot of patients are exhibiting very different symptoms. There's some other common thread between them which is causing this disease, or maybe there in no common thread. So of course common factors is that displaying it's pretty random, and you don't even know what lead to. Even here you can just say it would be an Ebola outbreaks, or by a person catches this disease or virus, he or she suffered from it. Or now the rules even in the human do not know in that case, despite having access to a lot of data. So then what do you do in such cases? So these are the exact 4 challenges that typically any large rule-based system eventually faces. Lots of data and inexpressible rules, and the rules unknown, and rule is being very complex. So these are the 4 challenges that you typically face, right? So this actually lead to a development of machine learning, and that's the idea is, instead of having a human who first comes up with these rules or tries to express them as a program. And you could see this program, for example, here we have these are all the things as like a function of x. So here let I just have, this is the function of x, right? So which is taking as this x as an input. So what is this x is all? Yeah, of course this x is all as like 10th grade or 12th grade, and this graduation, CGPA, all these together form the input x. And my decision making agent is the exact function, and this function of this f of x. And human, yeah, of course, and a human was actually writing this function. And with this, yeah, the idea is just we can remove, that is, actually we can remove the human out of this move and introduce this exact machine which directly access these data, right, and learns this function on its own. So instead of you coding this function, the machine has somehow figure out this function, whether or not just that it also, okay, so figure out some parameters of this. So how a typical machine learning setups looks like, yeah, what you have here is lot of data, right? So that is all the data which you given to given to the machine, and this is all the data that was given to you, and now you have this function depends on all these data, and with this you are just going to have f of x, and for what? Yeah, you are just going to identify the y, and that is the exact output. Okay, so although I have just written something as like this is f of x1 or comma x2, that is actually the function of this one would be x1, x2 till xn, okay, and these are your all x1, x2 up to xn, and all these data that you have, and now your decision relies on this function, and we just do not know what the function is. That is this definition of f of x, okay, so we doesn't know what the function. So unless the other case, whether or where you are able to write this function as a series of if and else conditions, now you don't even know what the function is like. So this is, you are just saying y is equal to f of x, and what is the f of course we don't know. We don't know even what is the function, and unlike the other cases where you are able to give certain weights to certain inputs, and as like whether if you are just going for programming, yeah, that exact weight, if you are just having C program or a Java program or Python or C++, of course each and everything is important. And here you do not even know what is the rules or what is the weight to be assigned to different parameters or different features. Or okay, now what you can do is, yeah, you can just say that you can specify the machine. Yeah, I think there is some relationship between these X and to the Y. That is this input, relationship between the input and the output. And I think the relationship comes from this family of functions X, either the linear functions or which are of the form Y is equal to mx plus c, or of from a polynomial functions of a function, that is you can have any polynomial degree as a relationship between x1 or x2, or you would have some non-linear functions like tan theta or sigmoid, any class of function. Here I just specified only the f of x, and that f of that function can be anything. And you can just tell the machine, yeah, look at all these data, okay, look at this input and try out all these functions and try to figure out which functions is best, and explains the relationship between the input and to that of output. And as even I can just say, yeah, this you should be very clear to you. It is very hard for you much to even think about doing this right. Because see, you cannot just say an arbitrary large number of functions. Try all of them out. Try to learn their parameters. Let's even you take a very simple functions like y is equal to mx plus c. Still you can just say simple linear data. Or even if you want to go for a complex, yeah, go for a 25th degree polynomial. Then you will have 25 to 26 parameters to learn, and all these coefficient of all the powers of x. So for an example, if you want to have a cube as like ax cube plus bx square plus c. So suppose you think that this is the exact relationship between the exact input and output, then you still need to learn all these parameters. So this task is what you are outsourcing to the machine. What you are telling the machine is that I think the input and the output are related by some function. So you try out all these functions. Yes, y is equal to mx plus c, or as like a linear or a non-linear or a polynomial. Try out all these functions. You try out different parameters values for them and tell me what functions and what parameters value actually best, or describes the relations between this f of, that is the relationship between the x and y. And once you give me that function, yeah, I just need to code up that function for any new input. I could derive the output by just plugging it in that function. So what machine learning actually enables you to do so. Now the crowd says, how do you define this function? That you can just try any arbitrary functions. So that what is good set of functions, or try once you try a functions in a simple case of line. It is very easy to find these parameter as like if you just go for simple m and c. But when you have an increasing complex functionalities or a non-linear functionalities, how do you estimate all these parameter efficiently? So what we need to learn, that's what machine learning is about, identifying these good functions and then identify how to learn the parameters of these functions. And dear friends, I just want to specify one thing. So kindly just see here, this is what the exact machine learning functionalities we are going to discuss. So it is already known to you. Yeah, we are having three different categories, that is as like supervised learning, unsupervised learning, and reinforcement. Yes, dear friends, these are the three things where under supervised we would just further categorize as like classification and regression. And when coming towards this unsupervised, yeah, we are just going to mainly concentrate on towards this cluster. And when coming towards this reinforcement, yeah, it is always, it is with of the rewards or awards maximization. So that is what it is simply specified like that. Okay, so in this manner, how we are just going to, or how we are going to discuss it further is, yeah, we are just going to take each and every component of the particular functionality, and then we are going to discuss it in a form. And now let me just see here, these are the exact component of machine learning, and how these are just, we are having a 6 jars and that interact with each other. And yes, of course, dear friends, we are just going to have it as like a story of machine learning, and so that this one, yeah, we are just going to make it particularly, and we want to give this each and every component. It is very much important. I just want to relate it, what is data, and with the data what you are going to do with that, and which is resultant with an task. Okay, and for this objective of this project, what the model you are going to do, and in such a case, yeah, what is the loss, and how you are going to calculate the minimizing functionalities of the loss. And once it is done, yeah, you are going to make this model to learn by the machine. That is exactly, the machine is going to learn the exact objectives of the model and towards the procedures. And once on making it, you are going to evaluate the performance of that model. So this is the main component of a machine learning. Yes, dear friends, we will be talking about the 6 jars of this machine learning. Yeah, let me look at the first jar, which is data. So anyone know anything about machine learning? Yes, knows that data plays a very important role. So in this model, yeah, I want to tell you exactly about what role the data plays, and for data to be able to useful for machine learning, in what form you need this data. So now today we have a data everywhere. I have said this is in the last session itself. Yeah, whether we eat or see, each and everyone having an social media platforms, you would have an logins as like Facebook or Twitter or any so many social media platforms are there. And here, yes, one such a particular, I'm just specifying, this is a Facebook, and where you have, of course, kindly just observe this image, you would have an types of data. Yes, here we have a text data and image data. Of course, some media related data is also there. And in such a case, kindly just observe, dear friends, this exact text data. Okay, and yeah, you would be observed to be seen. Yes, it is not an structured, it is in an unstructured format. And how would you just specify the structured? Of course, yeah, kindly just observe this. This is exactly a product website like Amazon, where I mean you have something as like an structured data. And yes, dear friend, which is in a tabular format, and yeah, you have also have an unstructured as like reviews or this stars, or you can have a product picture, and even some would have just included about the demo or something related towards the product. So yeah, video also would just be included. So how to use the product, that is also, yes, of course it would be. So on, you could have so many datas here, and let I just give you, yeah, here it is all about Ghana.com, that is as like something which it just has an MP3 collections of audios or speech data. Okay, and here what would be, yes, of course I have already specified, yeah, you have lot of audio or speech data, or you can have different modalities as like video of this album, Okay, video of this album, that is also be available on that. Because of this, yeah, you can also have image of that albums, and it is in structured, and you can also have a speech functionalities. Okay, so these are all comes in, yeah, different modalities. And of course, dear friends, machine learning, which is need a specific type of data. So let's look at what data you want, and let's look at one such an application. So the application here we are going is a medical image. So this here is a medical image, and based on that, it is you want to be able to train this machine to find out whether any anomaly is present or not. And that's the kind of application that you are trying to bring. So yes, of course, it's very important to understand here. And here the data here is of two parts. Yes, we have X as an image. Actually, it has a certain characteristics in such a case, and when coming towards the output, yeah, whether anomaly is there or not. And maybe here this anomaly, maybe anything sort of medical anomaly or so forth. And yeah, you can also say as like anomaly, as here we are having a brain image. Yeah, you can also specify it as like a tumor. And here this we are having it as like a data of X and Y, and here where X is the input and Y is the output. So now with this image and a situation where you're working for a hospital, or you have a hospital as a client, and the hospital comes and tells you, I have a lot of medical image that I want to be able to find whether the given image, if I taken any X-rays or a CT scan. Of course, here image data, there are so many things are there, dear friends. And particularly towards medical image, you can just go for CT or MRI or X-ray, and even in MRI, you can just go for structural and functional MRI. So if you take it as an image processing, it is really a huge data processing. It would be available. And if the exact requirement is as like, if I take a X-ray or some other scan of a person, you should be able to tell me whether the person has anomaly, or if it is an X-ray or any fracture. Okay, so that would be the first question that you need to ask. And you have a lot of data, but you have both the inputs. That means, do you have a lot of image, that is medical image, at the same time lot of each of these image which the doctor's judgment about whether this person have a cancer or not. Or if you can give me a lot of such image, I can train a machine to learn the relationship between, so this X and Y relationship. And then if you give me a new image, I should be able to classify it. So, but if you are only going to give me this X's without any information about the Y, then there's not much to like. Okay, so typically the application does not end. So they also want to explain in a sense that they not only want you to tell there's an anomaly in the image, they also wanted to find out the exact location where it is. So here again the Y is not just only zeros and 1. Of course, here we just need XY coordinates. And what would be the XY coordinates? Of course, if I just specify, here it is the exact image, and in this image here the exact anomaly is present, and what is the exact location of this. Okay, and here, you can not let me call it as like here you can just say this is x1 y1, and here you can just say as like x2 y2. This is the topmost point, and here it is the bottom. Okay, and so now you ask them that, do you have the data in this form? So where you not only have the image but also have the exact coordinate of that is this exact coordinate of that box. So in which the problem makes. So only then I can train a system or the machine. So now this is the entire thing, which is x1, x2 becomes my output y, and the image is my input. And my job is now to learn the relationship between x and y. And it is be able to learn the relationship. It is very important that your data has both x and what is the exact function, and which it just leads towards this y, of course. And if you only have x, yeah, you can do something known as unsupervised machine learning. But most of the success of machine learning today comes from the supervised setting. That is 99% of success actually comes from the supervised machine learning setting only. So for you to be able to do something or meaningful more often, that not it requires supervision, or supervision comes in form of human that is giving you the label associated with the data, right? So that one thing that you need to know what is the exact association. And second thing that you need to understand is that this data, whatever data you have, should be in some machine readable format, right? So in such a case of imaging, it's not very difficult. For an example, yeah, you can just make it as like if this is the exact image 28 by 28, which means if you are just specifying 30 or 30 cross 30, it means 900 pixels is there. Each of these pixels tells you the RGB value of that particular cell. Or in case this is just a black and white, yeah, for a particular cells you just have 900 such values, which can just write or enumerate as a single array. So that your input is, and what you are trying to learn is the relationship between which takes you from this number, this set of numbers, okay, to the output. And here, so your data first of all for supervision is whether you would have any relationship between this x and y, and the second data would be some machine readable, that is whether you are having or making those coordinates. So of course, dear friends, these two important things that you require for machine learning in the case of supervised learning, that is all data has to be encoded as numbers, and secondly, data could be very high dimensional. So in particular example, what I just is specifying as like 30 cross 30. Okay, so the data is actually you can just specify as like n real numbers describing each data points, and in this case the n is 30 into 30, it's 900. So with this, you need understand typically the data would be high dimensional. And well we can also take it to another example. Then you have here you can just have any document, text document, okay, and yeah, what do you do here? It is as like sentimental analysis, because this is a text input data, okay. And what the type of analysis? Yeah, whether the reviewer is talking something positive about the product, or whether it's talking something as like a negative or about it. So here again, remember that you need this x input and y output, where your x is the document and your y, that is the output marked by maybe as like marked is or labeled by the human. Okay, and I have such a lot of data. So such data, then if you give me a new review, I could build a machine learning agent to understand the relationship or learn the relationship between x and y, such that if I give it a new x test data, okay, or text, yeah, it should be able to identify the y, whether it is a positive or a negative. How come? By using the function f. So if you just relate this, yeah, towards the y, it would be possible. So here again you need both X and Y. Yeah, the Y part is important. And secondly, now you have the text data. So you should have a way of representing this text data as some numerical quantity. Because remember, dear friends, of course, the functions that you can learn are going to be in the form of Y, that is equal to f of X. Okay, and where Y and X both going to be numerical quantities, going to be a set of real numbers or a single real numbers or whatever, but they are going to be numbers. So you need to have a way of representing any data that you have to into numerical form. In the case of image, it would be very straightforward. You could just take the RGB value and let the number that you have. But in the case of text, it's not so obvious. So you need to understand how to represent the text. So this you have to do in some point of specification as like or concept like natural language processing. Okay, but let me just see it further how this encoding happens. Okay, now you require a little of text, so we will do a part of it whenever required. Okay, right, but it's very important for you to understand that the data has to be represented as numbers. Now coming to the form, so the data just need to be a text or image, or it could be structured table. For an example, this could be a past record of an employee, or I mean what his appraisal, or what about the experience, or how many teams he have worked for, or how many projects that he have worked for, whether his output or his feedback about that given by the client as like a satisfaction for every module, or that the person had delivered, or but on salary at different levels, how many promotions he or she got. That is also in a number. So all of this could be represented as in a structured data. And you can also have a data reviews or a text data reviews as like an example. And now the question is, how do you represent the text data as a number? So we would get to that at some point of then. So you could have the image in. Okay, so this would be as like an encoder, mainly as like natural language processing. And when we just go for this image, of course, you take the pixel value, and this exact image, it is very easy to represent it as numbers. You have to just take the pixel, that is the intensity value. And here even videos could be represented easily as numbers, because video is just a collection of image. Say 25 frames per second. So each image you could represent as a number. So now you could think of a video as a collection of many such numbers. And again, it would be very high dimensional data, and there are smarter way of encoding the video, and you would typically not do it this way. But again, that is something that we don't need for this particular session. We would just discuss it in further computer visions also. Okay, and yeah, lastly, you could have this speech data where you could represent it as different frequency or amplitude and so on. So again, you could represent speech data as some collection of numbers. So lot of data that we are going to deal with is going to be an image data and text data, or within text data also we are going to deal with data at a character level and not at a formal. Okay, so this will be become clear at some point, but right now we just need to understand two things: that the data has to be encoded as numbers, and the data is typically a high dimensional, or for successful application you need both the X, the input, as well as the Y, the output. That is, that all you need to understand about the data. Now important question is, where do I get the data from? Right. We have to create this, dear friends. Of course, if you have any such of difficulties in getting a data, I just specify some three different scenario. Possibly, see, actually, there is one, you are lucky. Okay, so you would have an data that is open data set repository available, and you can just say Google AI has a set of data set which are publicly available. You could go to an any governmental, international or Indian government data site, and you can just get it. And you can also find various data about different crops. Even there are so many data, even according to state wise or country wise, there are so many things are available. And even though population by states or different diseases, different plant diseases, and so on, long data also available on various websites, and you could see what you could do with this data, right? So you are trying to build an application, for an example, any sentimental analysis engine, and you could look at this Google AI, all these other repository listed here, and see a machine learning. You're actually for machine learning, you can just go for UCML repository. Okay, so many things are there, dear friends, and you can find some data which you directly use. Okay, so you can directly use, you have both X and Y format, so you would be lucky in that. And second thing, if you just but if you are a corporate or who is trying to build some application, yeah, you might need something as like a paid version, so you to actually aid this data. So there are several online platforms available, like Amazon Mechanical Trunk or Data Trunk or Figure 8. So these are very powerful crowdsourcing platforms also there. And crowdsourcing is also very important tool, and the important way of generating data for machine learning, and has been successfully used for various vision tasks, as well as this natural language processing task, and also for speech tasks also. There are so many things are there. And I could also, for an example, if you just say, yeah, I could upload a review on one of this platform, and then ask some crowd worker around, okay, so the world, to label whether this is a positive or negative. So not just that, I could also ask the worker to mark out the words in the document because of which he or she thought that this review is positive or negative. It all for this can now. So done. This can be done. So while crowdsourcing, it is very important for you to know about this especially. And if you are an organization, yeah, you could use this to curate very specific data required for your organization. And the last important thing is, yeah, something like usually whenever we just make it as like an, in case of I just don't want to make any wish to pay or to collect this data. Neither I am lucky enough for this data. So do we already available or some free platform, or I have to create my own data. So most of the things here, this my own data. Yeah, in such a case, you can just something as like simulation of data also you can just come across, but kindly just be aware where you can get the exact data, because see, as I have already specified, data would plays a very big role of a project. 75% of the project depends on the exact data. If you just choose a wrong data, of course the projects would end up with an low performance evaluation. Okay, now coming to, I can generate a lot of such data, and since I am generating data, I am not only have control over where I place the text, or I can also exactly get the coordinates of whether the text is right. So this is something that we are going to do in this case. In this case, actually, see, actually we are just making us like a sample and we want to have an demo or hands-on. So in such a case, you can just generate by your own. That is what I just suggested. Okay, yes, and yeah, dear friends, it is generating, it is not much tedious. Of course, you can also have so many now indeed in advanced apps like Gen AI, there are so many automatical generated data is also it is available, and using various image processing tools and very simple engineering exercise also. Okay, so we are also can use something known as Wikidata, which has a lot of collections. Okay, so that's the first jar. Yeah, of course, the first jar is the data. Okay, so here we got introduced about what is the data, and now what we are going to do this data with. Yes, dear friends, as we have got introduced to the first jar of machine learning, which is data, and now we will look at the second jar. So right so far, because we go ahead, once we have this data, what do we do with the data? Now here it is a typical example of data. You have various things here. So for example, this is a product page of an Amazon. Okay. So let's look at all the data that you have, or you have image, yes, you have image data. Okay, you have an structured data here, of course, unstructured descriptions also here it is there, unstructured, this is reviews and commands. So these are all unstructured informations in forms of reviews about the data. And yeah, coming towards this structured, of course, here, even though if it is description about that project or that product, what it is, or what is the operating system, or what is the RAM, and so on. Okay, so lot of information here, it would be in description as like unstructured. The same thing here, it would be in a tabulated manner as a structured. Okay, and some description given by the vendors, or remember, dear friends, Amazon is a marketplace. So some vendor would have posted this product and also give some description about it, which is a bit unstructured, but may also have some structure in it also. Okay, so you have information about that related products which are similar to this particular gadget, or here it is as like a phone. Okay, and then you have FAQ and other question and answers by the user, and their answers. Actually, see lot of data, and within this abundance of data, because there's too much being thrown at you, and now you are not sure what to do with this data. Okay, so the first thing that you need to figure out as a machine learning practitioner is that when data is thrown at you, what are the different tasks? Okay, what are the different tasks that you can do with this data? So in this case, over this particular data that I showed you, I could define many tasks. Let me just go one by one. The task, what are all the tasks? Okay, so here let be the first task looks at a very simple task that given here it is as like highlighted in red here. Okay, so this exact part which is here is some unstructured information about the product which was uploaded by the vendor. And yes, of course, the machine can automatically, the machine is trained automatically to make it as like a structured data. See, for example, other words here, this would be my X, which is an unstructured information, and my output Y is a structured data. Here I want to train a machine to be able to learn the relationship between this f of x and the y. So now this is again very important, because Amazon would want to take this unstructured data and populate it, okay, populate in its own data, so that it has a better idea about what different products it has or what are the specification and so on. So this one task that you could define over this data which is belonging or which is being thrown at it, but not just that, you could actually define some other task also. Okay, what is the next? So see here, for example, now the next task is, so you could take these red box, that is here one and here one. These red box which I have highlighted here, so which is the reviews of the product and also the specification of the product. So this could now be your X, and the combination of these two X, using this, yeah, you also have an information about the different FAQs that are important for this product, right? And now suppose if I just give a new product for which you have reviews on the product specification, yeah, you can automatically come up with a set of or list of FAQs. In another way, yeah, now your machine is interested in learning relationship of the form where your input from this f of x, where your input x is the review and the product specification. So here you have x1 and x2 as your inputs, okay, and from that f of x, the reviews and the specification, and your output, you can relate it towards this is what your output, and it's some questions which can be asked about this product, and you have this data, and that you have both the x and y on this page itself. And you have this for multiple products. So you have multiple data points from which you can potentially learn this relationship, right? So this another task that you could define on a snapshot of this. Yeah, kindly just understand, dear friends, same data, na? So it's very important to map this data to some useful task also. You can just, here I'm just specifying this is as like one of the text, or here it is one of the text. Yeah, kindly just relate it with some other data also and do some same suches of the tasks. Okay, now get another task that you can do is, given the information about the reviews, this one x1, the product specification x2, and what you have just given this, the x3, the FAQs, you can answer and have any questions. Okay, so which a random user is asking. So now if you go on Amazon and you also have this section, yeah, no as customer questions, right on. Okay, so now if you read these questions, read this right from more often, that not you will find that they are answerable from all the information already available on the product page. And the answer might either be hidden in some reviews, or for example, see, user might ask, so let I just come up with this frames. See, actually, if you, not only this Amazon page, even if you just open any inquiry related of us like in website, some chatbot would just comes up. And whatever the question or whatever the inquiry you throw here, yeah, no one would just sit 24/7 to answer your questions. So here what it happens, of course, all these combination, it is taken as your input and simultaneously the output is thrown to you. And here I just must say you one thing. So see here, if one particular like this an Amazon page, I'm just asking here, what is the exact battery life of this gadget? One would have just specified some any reviews. Yeah, I played games yesterday. Yeah, this was used for 4 hours. I just used it for 4 hours, and after that the battery drained out. And some would have just given a good review. Yeah, I have just used it on a travel. I watched 2 movies. Of course, it can be just taken that exact data. The 2 movie would have just considered as like in 6 hours, and so that you would just get the output as like 4 to 6 hours would be the lifetime of this. These are the thing, dear friends. Actually, remember we have two conditions. One is for this supervised, we need X as well as Y. So which I am trying to convince you that a lot of such X and Y pairs are available on this page. But the other condition that we had in is for any given X, we should be able to convert it into numerical data. And in this case, all these X's that we are dealing with, yeah, whether it would be reviews or a structure table or a questions in FAQs, all of these text data, and at this point we don't have to convert this text to numeric, but you can take my word for it that this is not a very complicated process. There are very simple way of taking any textual data and convert it into a numerical representation. And once you have that and this X and Y pairs, you have a task defined. So from that data, your job is to define various tasks that can be solved. Actually, task is nothing but a crisp definition of what your input is and what your output is. Okay, let me just go for another task. So you could do here is that you have an information about an user, okay, and you know that this user is John, and you know which project page he is looking at currently. So what are the different attributes of that page, and based on that you could recommend. Okay, you could recommend your product to this particular user based on this purchase history points. All right, this is yet another task. Okay, so that you could do from the data that you see on this particular page. So here it would be reviews and comments and structured data, tabular manner to the user. You can just give some recommendation. Okay, and now let's look at another example. So there are a lot of appointments updates as well as you will look at towards this social media pages. So what are all the things? Lots of data it's available, dear friends, as like images, text is there, as like audios videos you also can be included. So there are so many unstructured related on data would be available. And now you could define several input output tasks here also. So now one such a task, what I am just going to give is a very simple thing. Okay, so one such a task could be, so given an image data, okay, given an image, kindly identify the object in that image. And here, not only that, yeah, of course, it is actually what Facebook does. Okay, so if you upload some image, yeah, with your friends, it automatically tries to tag those images. So now the task is here. Yes, of course, one image is that input. Second one, yes, it is identify the faces. One task. Second task, it identifies the user. That is tagging the user. So the task here is an image tagging or a person identification, and for that the data you need is, for this you have the X as well as the Y, and which is bounding box around that person as well as the label of that person, right? So you have two types of Ys in this case. So your input is clear, that is X, and your Y is, one is rectangle, that means the coordination of the box, that is X1, Y1, X2, Y2, okay, coordinates, as well as the label of that user, that is the box. So this is some input output pairs that you need if you have that, which is there in this particular page, and you can define this as like an image tagging task. Okay, and another task that you define based on the data available on this page is, okay, activity recognition, identifying the activity. So you given an image here, Okay, someone somewhere in this post. So it is also mentioned that someone is eating some food or something of that sort, like that. Here it is. Or you can just say, yeah, me and my friend had a good dining, or we went for an organization or some restaurant, like that. Okay, so here somewhere in this post it is also mentioned that someone is eating some food or something of that sort. So you know that the input is some image and the output is a label associated with that image or activity associated with that image. So if I get this table, such pair, you should be able to do this task of identify activities from image. So this is another task that you could define from this data. Okay, so and here this output is eating. So here, dear friends, of course, there would be so many machine learning model that would have been given. Some would have just specifying eating. Some model that has been trained longer and high performance would just comes as like dining. Some can be as like in serving food. So many things happen, but here towards the machine trained thing output, we just getting an eating. Okay, we just getting the label as like eating. Okay, now next could be that given the same an image identified with location of the table. So again, Facebook. Okay, here people upload a lot of images and have say eating food at a place here. Say as a restaurant or near a beach, or say beach, or and here in a gym, you can just say. Okay, so again this input output pair, that is x comma y, are given in various images for various things is there. Okay, various concepts. And here Facebook, you could take this input output pair and design the task of image location identification. Okay, so that one more task that you could do for this data, that is when you just make use of this particular data. If you just find here, so this would be as like the data location, and see here, if you just find any yoga mat here, it would be as like a meditation. And here we are just identifying the gym equipment, so it is specifying gym. Or even though you can just say this machine trained word as like gym. Yeah, you can also specify it as like a workout area. Okay, yes, these are all the things, dear friends. And now if I just go for one more task, yeah, could recommendation. Okay, so here recommending some similar thing. So based on the post information, the textual information, you could recommend similar post or other post or similar activities again. Okay, so this information that is also available for the main same Facebook in the form of X and Y, and you could exploit that, get lot of these X comma Y pairs and then train a machine to learn the relationship. It is how to do. This is a question that we will tackle later. Okay, how these are done and how the exact model is just doing. Okay, but the first thing to do is, once you have identified the data, identify the task that you could do with this data, right? So, okay, now these tasks could actually be of various categories. The first important category of task is whether it is supervised setups or task, and here how it is just relating it. And coming towards that same thing, dear friends, if I just go for a recommendation, see here, the two such an example I can just give. So this is actually a dining. I'm just specifying, yeah, me and my friend had a good meet at an XYZ restaurant. And if any particular event, upcoming event, or any special event, or even any celebrities, they are going to or having any event or upcoming any openings or any branches of franchises opening for this XYZ, yeah, that can becomes as an recommendation for you. And even though if you just specify this as your recommendation poster, if this would be the X, what would be? What would be the Y? Of course, yeah, any offer for those annual subscriptions or new opening of an gym nearby. So that comes as like a recommendation. So all these comes towards, dear friend, of course, everything are related towards the X and the Y combination. And I was describing earlier in the supervised setting that is both X and Y are important. It's not just enough. If you have a lot of images, you should also have the labels for those images. So in this case, yeah, I have a lot of images. Okay, so in this case I have an images and the label here is actually telling me whether this exact image has a text or not. So here, of course, this exact, whether there is a text in an image or not. So now I can build a classifier. Okay, I can build a classifier which learns the relationship between these X and Y. So learns this relationship, and the output of this classifier, see, kindly just observe, dear friends, here we have X, and with this you are identifying the Y. And what is that exact Y? You are having ones and zeros. So depending on whether the image contains text. So see here, this contains a text, this contains a text, and here you are able to see the text. So it just classify whether the image contains the text or not. And so this is the task that you need to perform. And here, dear friends, classification is an important category of a task. Many of the tasks that you do within a real world are mostly likely or going to be a classification task. Okay, and a large set of tasks that you do. Okay, the other important categories of task is, of course, let me just go for regression. Okay, so other important categorical task is of regression. So now in the case of regression, I'm not just interested in knowing well that given an image which is an input X here. Okay, it's not just interested in the output of zeros or 1. Then what's there? What's there? Yeah, I'm not interested actually towards this zeros and 1. Rather than, yes, of course, dear friends, kindly just see here what we are having it is as like a left to X, left to Y, width and height. Of course, in actually finding some real values which tells me the coordinates of a box, in which the text makes, okay, so right, so let me just explain this. So this is my image here. I just want to know, okay, I just want to know exactly where the exact text part is present. So in this I want to know the leftmost coordinate, and rather than the X coordinate, here we have the left X. Okay, so X coordinate of the leftmost point of the box, and Y coordinate of the leftmost box, and not only that, the width of the exact box and the height of the box. And yeah, if you know all of this, yeah, I can actually find the exact box, because these are the 4 pieces of information I need to find the box. And that's exactly what I want, to find an image which is the box in the image which contains the text. So this is typically a regression problem. Okay, so where a given input you are trying to find some real values. And here, dear friends, I'm not trying to classify it into one of the categories, but you are trying to find some real values of importance to you. In this case, the values of importance are the coordinates of the box that you are looking for. So such tasks are known as regression. So another regression task which would be, which typically is, yeah, you have a lot of stock market data, how do you predict the price of the stock, and in the next few days, or things like that. Okay, so how do you predict the box of its connection of a move and something the next important. Okay, so you can just go ahead, or else if you are just having this image, here we are having text. Other than that, if you just go for a medical, yeah, there we have already discussed, that is, this is one x1 y1 and x2 y2. What is this? With this coordinate, you are identifying the anomaly present, whether it is present or not, and if so, where it is present, the coordination. And in medical thing, yeah, it is just specified in the manner of region of interest. Okay, so these are all there. So other tasks are also there. You can just make use of this regression concept. And yeah, let me just go to the next important category of task, which falls in unsupervised category. Okay, so in fact, in this actually unsupervised category, see, actually here the last two tasks that we have specified previously were supervised task, and there's also unsupervised task also that. In fact, if you give me a lot of image, I could use something a clustering. Okay, so that is also can be done. So kindly just make use of the concept where you are, and to the same thing, dear friends, I'm just specifying what do you want to do. That is very much important. What do you want to do? That is the main task. Okay, so kindly understand and go ahead. Okay, so here in this particularly, what we are going to do is, let me have some examples. So yes, I could see things like clustering. What is clustering? Of course, clustering is grouping with a common. Okay, in fact, we are going to have something grouping among common, but here what is the commonality? Of course, every images are having a text content. Okay, so yes, let we in fact, if you give some lot of images, and I could do something on clustering. So these are all image data that you have given. Something known as clustering is in the sense, yes, of course, commonality. Okay, so I don't know what is here the y variables, because of course as an unsupervised, I don't know y, that is not labeled. Okay, what each cluster means here is, yeah, if I look at these datas, it's clear to me that one cluster here is actually containing all signboard with a yellow. Is it so? Yes. So see here, these are all yellow boards, and here it is green, and something as blue. Yes, of course, I can categorize this. Okay, and containing a signboard which are all yellow in color. And yeah, this is a cluster that is signboard which are blue in color, and this cluster is containing all signboard which are green in color. And the catch here is that, dear friends, of course, as a human can interpret that this is what the cluster is actually doing, but in the reality there are new labels associated with the cluster, right? It just happened that in this case, all these images nicely fitted to these three clusters. But I could have also learned alternate cluster where one cluster could have contained all as like a geometrical shape, as like a rectangular, and another cluster could have contained all the rhombus like images cluster. Cluster could have contained all circular images, right? So that could have also happened. I have no control of what the syntax of this cluster. So basic, I don't have the associated Y labels also, because here we are in unsupervised. So the machine will try to find some pattern, and it's up to you to interpret what exactly is happening in those patterns. So that's what, and this is also useful, and it's not that this is not actually clustering of data organizing is not into some unlabeled categorization. So it's also a useful task, but it will only get you so far, because that's about clustering. It is there is a huge variety of combinations is that. Okay, as I have already specified how you can just interpret. And another last important category of task that I am going to discuss about is something known as generation. See, where actually I have been giving a lot of images. So these are all my images or paintings, okay, by a particular painter. You can just specify anything or something, okay. And now my task is train to make this. Here we have this excess, okay. We are going to train the machine and we can generate a new X here. So this is what exactly comes under Gen AI. We are just giving here as an image, expecting output as an image, giving a text, expecting an image, giving a text, expecting as like a video, giving an image set of images and expecting an output as a video. So you can just have any such a combination in Gen AI. Okay, one such a things here, what I'm just giving is, so here we have a set of similar X's, okay, that I have here, and now we are, as there is no Y, okay, so that is also you just have, there is no Y, so there's no output here. So I have an input which is a lot of images given to me, and now I want to generate a new X and which are similar to the image and which I have seen. See, actually I don't know whether this would be the exact. Okay, you would have heard about this context through that GANs. Okay, so that also comes here, generative functionalities, and which can now generate such image which are inspired. So to save all images of famous pain or that is one task that you could do it in generation functionalities. So with this combination of X's, okay, you are generating a new X. So that is what here I am not specifying it as like a Y, because Y it is actually in a label, and here it is I am not labeling. I am generating a new X. That is what here it is specified. Okay, yes. Similarly, there's another funny task that you might be available, that is you might be aware also. And you are giving a lot of tweets, okay, actually you are given a lot of tweets by, of course here it is by Donald Trump, okay, so Donald Trump tweets by which were made by him, okay, all these are my X's that you have, and now you want to generate a new tweet which are again this X, and here also there is no Y again, okay, so here which looks similar to this tweets that were made by Donald, okay, so this is another generation task that it is very important task, and there are actually some Twitter handle which was posting such as funny task which looked like as if Donald was tweeting. So it's followed a similar language as we use it, okay, so similar sentence or similar slang or sentence structure, okay, so on. So this X here looks very similar to this X's that you have seen as towards the input data. So this is the mean, that is something which is unsupervised task, but the key insight here, that is this attributes is one of the statement which Andrew had made, which is supervised learning is actually responsible for 99% of economic value created by artificial intelligence. So most of the tasks that generates values are supervised learning tasks. So where you have both X and Y combination. Okay, so yes, dear friends, so that brings you to the second element of machine learning, and in which the task, okay, so is the right. So that you had data. Once you have the data, you define these tasks, okay, so this machine learning, it just we have discussed about under supervised, We have just discussed about what is classification, what is regression, and when coming towards unsupervised, yeah, we have just seen about what is clustering and few related towards this generation. So yes, dear friends, here we just finished the two modules, that is one is data and task. Let me just end up here. Okay, so I think this exact video would be interesting, and thank you for watching the first part of our machine learning series, and we hope you have a solid understanding of initial step in the machine learning pipeline. And yes, from data collection towards how you are just going to process it. And kindly, dear friends, stay tuned for the next video where we will dive into model selections and training and evaluation. Don't forget to like, comment, and subscribe to the, and of course, stay updated with our latest content. Okay. Thank you, dear friends, and happy learning.